So now that we're done with chemical bonding, or at least the theory part of it, let us try and understand these concepts better using some questions. So the first question that we will do today is called, what is the hybridization of PCl6-? So Devansh, why don't you tell us some ways to solve this question?
Yeah, first of all we know the basic formula. X equals to half V plus G plus A minus C.
Okay, so now what are these four terms?
Okay, V stands number of monovalent atom attached to central atom.
Number of monovalent atoms
Attached to the central atom.
Okay, to the central atom. So what would an example of such a monovalent atom be?
Like H, Cl, fluorine, all the halogen compounds,
Okay.
hydroxyl group, etc.
Okay. So these are all monovalent. So what would you say about, say, double bonded O? Will we count it as 1, 2 or 0?
No, it will count it at 0 because it's a divalent.
Okay, so it will not be 1 or 2, it will be counted as 0.
Yeah.
Alright. So what is G?
G is number of outer shell electrons in
Okay, number of
outer shell electrons
Okay.
in ground state of central atom.
Okay, in the ground state of the central atom.
Yeah, because basically here we are finding the hybridization of the central atom, that is in this case is phosphorus.
Okay. Alright, then what will A be?
A is magnitude of charge of anion.
Magnitude of charge
Of anion.
of the anion. Okay, so will this be just an integer? Can we have will we write a -1 or a +1 or +2 or -2? How
It will be a whole number because it's a magnitude. As you can see in the case of PCl6-, it's an anion.
Okay.
And the charge over it is -1. So
but the value of A will be 1 or
1.
-1?
It will be 1 because we are going to take the magnitude.
Okay, and the sign portion of it has already been accounted into the formula here itself,
Yeah.
right? Okay. So what is C now?
C is magnitude of charge of cation.
Magnitude of charge of cation.
Yeah.
Okay, so in this case, what will the value be?
In this case, it's an anion, it's not a cation, so the value is automatically 0.
Oh, alright. Yeah. So let's put this into the formula.
Yeah.
So we get X is equal to half of.
Here V will be 6 as 6 chlorines are attached to it.
Okay, so there are 6 chlorines, so consequently we're gonna have a 6 here. Okay, what else?
Then
What do we do about G?
for G, we have to go to the electronic configuration of P, which is 1s2,
Okay,
2s2,
1s2,
2s2,
2s2,
2p6,
2p6,
3s2,
3s2,
3p3.
3p3.
As now we have said, we have to find the number of outer shell electrons. So the outermost shell is 3
Okay.
So therefore the number of electrons in this is 2 plus 3, which is 5.
Okay, so we'll have a 5 here. Alright.
So G is 5, and as we have already discussed, A is 1
Okay.
and C is 0.
Okay. So what we basically get is X is equal to 6.
Yeah.
So now once we get this number, now 6 is not the hybridization, right? What
Yeah.
will the hybridization be?
As we know from the table which I have discussed in theory, X is 6 and 6 implies sp3d2.
Okay, so this implies
sp3
3
d2.
Alright.
As you can see here, 6 orbitals are involved, 1 of S, 3 of P and 2 of D.
Okay, so 1, 3 and 2. So how will we draw this out as such approximately?
And we know from the table it is square bipyramidal.
Oh, so it's a square
Bipyramidal.
Pyramid. Okay, a very long name basically. Okay.
Yeah.
So we have that. So
Its structure is like this.
So the structure will basically resemble a P being in the center,
And 4Cl.
which come out of it,
Huh.
and
on the square plane and 2Cl on the axial plane.
Okay, so this is how it's approximately gonna look like.
Yeah.
If I connect the dots, and so I'm gonna have a plane here, and there are gonna be two CLs perpendicular
Yeah.
to the plane as such.
And a minus charge over the whole molecule.
Oh yeah, alright. We shouldn't forget that.
Yeah.
Yeah. Okay. So how about we try and understand this in a little more detail using orbital theory now that we've understood the formula?
Yeah.
We should also, I think, make it very clear to our viewers here that the formula that we've talked about here, the beginning of the chapter, which is the formula with X, is very, very important. Even though it may seem like a slightly lengthy way to do things, and we're going to discuss a shortcut sometime later, you need to understand this and imbibe the concepts in this very clearly before you can apply the shortcut. So practice this on multiple questions. Towards the end of this, we are also going to try practicing it on some more questions. So let's understand based on orbital theory, how can we solve this question?
Okay.
So what do we do?
So first of all, we know the configuration of P in ground state is,
Okay, it's 3s2. So I'm just going to write out the outer orbitals, right?
Yeah.
So it's going to be 3s2 and we have
3p3.
3p3. So let's arrange these out. We know that, well, S has just one chamber. So S is going to have one up, one down, and P is going to have one, one, and one.
according to the Aufbau rules.
Okay. So, and
And
3D,
we will be having 3D 0, means the 5 orbitals are empty of D.
Okay, so these are empty. So now what do we do next?
Now we give them some excitation energy,
Okay,
so
so-
that the electrons of 3s can jump and one of the electron can go to 3d 0 to make it 3d 1.
Okay, so the electron is going to jump from
3s2,
from P to D or from S to D?
it's
Which-
going to jump from s to d because s has 2 electrons.
Okay, so how does it happen? Does S go from S to P and then another one goes there, or is it a direct path jump?
It's a direct jump.
Okay, so it's the direct jump and this is the way it's going to go about. So what we now get is we're going to have the 3s orbital, which will now become 3s1. We're going to have the 3p3 orbital, which is going to continue to have the single ones. And now we're going to have a 3d1, alright, with one.
Electron in the starting.
Okay, alright. So now what do we get?
Now, as we know, it's a anion and it has got a -1 charge. So, one more electron will come and it will make 3d2.
Okay, so this negative charge will come in here and we will see another one here, right? So, and this 3d1 will as a consequence become 3d2. So, what we'll finally have is we're going to have 3s1, we're going to have 3p3 and we're going to have 3d2. So, this is going to effectively look like this. We're going to have a lot of these electrons. Yes, some of the rooms are bigger for the electrons. So now we know that we've arrived to 3s1, 3p3 and 3d2. So what is the next step with us?
Next, all the chlorine will give one electron to all 3s, 3p and they will form a bond. This is how an sp3d2 bond is formed.
Okay,
And now
so
as 1 from 3s, 3 from p and 2 from d are involved, that's why we called it sp3d2 hybridization.
Okay, interesting. So this basically becomes sp3
D2
d2 hybridization. Okay.
So this is how a molecule is formed, and the hybridization of the central atom phosphorus has sp3d2
D2, which is bipyramidal as such.
square bipyramidal.
Square bipyramidal, exactly. So how about we give a shot to some other examples as such. Why don't we try finding it out for PCl 4 plus? Yeah, let's try out
Okay.
another interesting case.
So here first of all V is 4 as there are 4 chlorine.
Okay, so V is equal to 4.
Now as we have already find out the G for phosphorus, so it's 5 again,
Okay.
3s2 3p3.
Okay. The A is going to be 0 this
A
time.
is
because
going
it's
to
a
be
cation.
0, yeah.
Alright, very good.
And now the cation having a plus 1 charge, taking its magnitude, it's 1.
Oh yeah, so taking its magnitude, we have to be very careful. We must not write -1. C is equal to 1 because the minus sign is already taken care of in the formula x is equal to half of v plus g plus a minus c. So if we write it as -1 here and then we put it in here, we have a problem with becoming confused. So always remember, this is going to always be the magnitude of it. So let's quickly put this in. The value of x that we consequently get is x is equal to 4 plus 5 plus 0 minus 1, which is basically equal to 8 by 2, which gives us 4.
And 4
effectively means
sp3, which is a tetrahedral structure.
Alright, so tetrahedral. So we very clearly easily done this. How about we try out another example where instead of all the atoms being monovalent, we're also looking at atoms which are
Divalent?
divalent as such. So let's move on to the next question.
Okay.
So let's try solving it for a divalent atom. So here in front of us we have HClO3. So how should we go about it, Devansh?
Yeah, HClO3, for this we have V equals to 1 because only one hydrogen is attached, which is a monovalent atom.
Okay, so for G, how are we going to find it out?
Now you should remember, here our central atom is Cl.
Okay.
So we need to find the electronic configuration of Cl.
Okay, which will
Which
be
is
neon 3s2
3p5.
3p5.
So as you can see, in the outermost shell there are 2 plus 5, 7 electrons.
Okay.
So therefore G for this compound is 7.
Okay. So this is not an anion, so it will be 0.
0.
And if it's not a cation, it will be 0 as well. Which consequently means it's going to be 4x, the value of x.
Yeah, and again it will be a tetrahedral structure.
Which is
sp3.
So there's an interesting thing I'd like to point out. How about if we remove the hydrogen and we only work with ClO3 minus? So do you think the hybridization of the central atom will change if any of the atoms attached with it are removed?
It depends which atom is getting removed. Is
Okay,
it a negative one or is it a positive one? If in this case H plus is removed and it is becoming ClO3 minus,
Okay.
here the hybridization is not changing.
Okay, so let's try and see why it doesn't change based on our formula. So we get x is equal to half. We don't have a hydrogen anymore, so this is going to be 0. There are no monovalent atoms. The G is going to remain the same, which is 7. But now that it is an anion, we will have a +1 here, and obviously it's not a cation, so it will be a 0, which still means that its hybridization will be 4, which still means it's going to be a tetrahedral structure with an sp3 configuration as such. Okay, so we've now realized that even if we remove one of the atoms attached to the central atom from our original compound, the hybridization doesn't change.
But in this case, we have removed a more electropositive atom from a electronegative central atom. If it would have been case like FClO3, and if we have removed F, then the charge on central atom will be ClO3 plus.
Okay.
And here its hybridization will change.
Because if you look at it, initially x would have been equal to half 1 plus 7.
No, 0.
No, in the first case with F, right? So it will be half plus 7 plus 0, which would technically mean it's 4. But in this case, it would become half of, well, there's a 0, there's 7, there's 0.
But here's a minus 1.
So what we'll end up having is 3
and then sp2.
So you have to be very careful, and you have to understand that even if you remove a hydrogen atom or if you remove a fluorine atom, it's going to have a lot of differences, and the hybridization of the atom can consequently change based on the atom that is removed from it.
Is it like if you remove a more electropositive element, the hybridization will not change, and if you remove an electronegative element, the hybridization will change.
Okay, so now that we are clarified with this, let's move to the next question. After that question, let's come on to a very recent question that has come in JEE Advanced 2014, which is a basic case of match the following. So, if you remember the theory earlier on, you'd be very easily able to identify
That in the first one, the first and second are the d orbitals, and in the second image you can see the first one, the dumbbell shell one, is p, and the second one is d, and the third one it's same again, p and d, and in the fourth one it is dz square with a ring and a d orbital.
Okay, so we've just jumped into solving the question, but I hope you understand that the match the following basically says that for these orbital interactions that we have on the left side, we've got to find the equivalent form of bonding on the right side.
Yeah.
So we've identified the orbitals now. Let's try and understand how we will be able to correlate the left side of the table to the right side of the table.
Okay, first of all, you have seen that in the right side they have asked about the bonding. What type of bonding it is, whether it's a bonding molecular or whether it is anti-bonding. So first, let us assume the shaded part to be plus.
Okay.
So then the unshaded becomes minus, just a sign convention.
Okay.
So you can see in the first and the second image, a constructive interference is happening, which is basically the interaction of minus and minus in the first one and plus in the second one,
And minus as well.
yeah,
Right?
so
okay.
this is what is a constructive interference. When the same kind of orbitals overlap, so they add,
Okay.
and that is what constructive interference is.
So constructive interference means bonding or anti-bonding?
Constructive interference means formation of bonding molecular orbital.
Okay, so we have bonding MOs with constructive. So we now know that for the first and the second, the only options available are, well, the second and the third on the other side.
Yeah.
Okay, so how, and now we already know that there are two D's in this one and there's a P and a D in this one. So we can very easily say that for the second one, the option is going to be, let's call them A, B, C and D. We can clearly see that for the first one, the option is going to be B because it's a DD bonding, sigma bond as we call it, and for the second one it is going to be C because it is a PD bonding as such. Now
Yeah.
what about the other ones?
Now we can see in the third and fourth a destructive interference is happening, that is overlapping of a minus with a plus in third,
Okay, and a plus and a minus.
plus and a minus, and a plus and a minus in the fourth one.
Okay, so we know, obviously we also understand that it will be either A or D.
So from destructive interference, basically anti-bonding molecular orbitals are formed.
Okay, so we get anti-bonding MOs. ठीक है, तो अगर ये एंटी बॉन्डिंग एमओज आ गए हैं तो अब हम वैसे ही पी और डी और डी देख सकते हैं. डी और डी देखने से हमें दिख रहा है कि चौथा है उसका ऑप्शन होगा ऑप्शन डी विच इज़ डी डी सिग्मा एंटी बॉन्डिंग, और जो इससे ऊपर वाला है उसमें तो बचा ही ए, तो ए हो जाएगा. एक चीज़ देवांश ये बताओगे कि ये जो हम सिग्मा और पाई सिलेक्ट कर रहे हैं ये क्या, इसका क्या मतलब है?
जैसे ये क्वेश्चन तो आपने सिर्फ इसके बेसिस पे कर लिया, लेकिन सबसे मेन कंसेप्ट इसका क्या है कि व्हाट इज द सिग्मा बॉन्ड एंड व्हाट इज पाई बॉन्ड. जो सिग्मा बॉन्ड है उसमें डायरेक्ट ओवरलैप हो रहा है, मतलब इंटरेक्शन ऑफ ऑर्बिटल्स आर हैपनिंग लाइक दिस.
So the interaction is happening like how it is happening in the first case, where there is a direct overlap of these two particular atoms.
So this is how in the center a sigma bond is formed.
Okay, so this is basically a sigma bond. Alright, and up in a pi bond, what would be the difference?
In a pi bond, like you can see the example third,
Okay, so in the third case, as we can see, it would be
they are doing side overlap.
okay.
Means they are not overlapping.
So they're
Directly.
not overlapping directly, and they're also consequently overlapping at two locations if you look at it.
Yeah.
So which would, well, consequently mean that this is a pi
A pi
bond.
bond.
All right. So now that we have it cleared, you're very capable of being able to solve all of these. As you know, there are going to be three methods on which you're going to evaluate it. You're first going to evaluate if it's going to be anti-bonding or bonding. Then you're going to see what are the orbitals involved in it, and on the basis of that orbital you can identify whether it is a DD or a PD or whatever. The other third method is where you'll be able to evaluate it based on whether it is
Whether sigma bond is a pi bond.
or a pi bond. Because what could happen is in this question there are only 4 options given, but you could be given 8 options as well with sigma and pi, where they could say PD sigma bonding, and it could be an entirely different diagram as such. So you have to understand that these are the three things that you need to remember, and once you do, all such questions, questions very similar to something that
All
came,
the
as we said,
questions-
in 2014 JEE, can be solved by you.
All the questions relating to anti-bonding, bonding molecular orbitals, pi bonds, sigma bonds, and interaction of P or D or maybe F or S, all the questions can be solved on this basic principle.
Alright, let's move on to the next.